Hello and welcome to today's lessons on applying arithmetic sequences. So today's objective is scholars will apply arithmetic sequences to real world situations. So we're going to apply these to the real world. So how can we apply arithmetic sequences to the real world? So let's look at this situation. A group of friends went to a museum. In the first hour, they saw 2 exhibits. After 2 hours, they'd seen 5 exhibits. They had seen 8 exhibits after 3 hours. So, me to think about this, I'm going to make myself a little table. Here's going to be my hours, and here's going to be my number of exhibits. So, I see the first hour, hour 1, they saw 2 exhibits. After 2 hours, hour 2, they had seen 5 exhibits. And they had seen 8 exhibits after 3 hours. We're being asked to create an arithmetic sequence for the nth term. Or we said the nth term is just any term. So if we remember from our previous lessons, our arithmetic sequence for is a sub n, and the nth term, equals a sub 1 plus n minus 1 times d. So we need to find our first term. Well, our hours are going to be the number, is going to be our term placement, our n number. That means our exhibits are going to be our terms. So if I write this as a arithmetic sequence, the sequence is 2, 5, 8. So that means 2 is my first term. So, a sub n equals 2 plus n minus 1. Now I need to find out what d is. What is my common difference? Well, let's see. Here I am adding 3. Here I'm adding 3. That makes my common difference 3. So, it's 2 plus n minus 1 times 3. That's it. That's how I find it. So let's look at another thing with this. So what if now they're asking us the same situation to find the 6th term? Well, we know we wrote our situation, our sequence already. It's a sub n equals 2 plus n minus 1 times 3. So now we're being asked to find the 6th term. So we're just going to replace our n with 6. So a sub 6 equals 2 plus 6 minus 1 times 3. 6 minus 1 is 5, so I have 5 times 3. 2 plus 5 times 3 to find a sub 6. Well, 2 plus 5 times 3 is going to give me 17. So a sub 6 equals 17. But then it asked me to do something else. It asked me to interpret the solution in terms of the situation. So we need to think back to the situation. So what is this situation? The situation is a group of friends went to a museum and they're seeing exhibits. So what does the 6th term mean in terms of this situation? Well, it means that they saw 17 exhibits. So they saw 17 exhibits when? Exhibits after, remember the first part was the number was how many hours? After 6 hours. So we have to go back to what it means in terms of the sequence. So the 17 was how many exhibits they had seen. The 6 was how many hours it had been. Okay, so not too bad. Let's go on. Well, this is a little different. Sorry, and this again should be a sub n. It didn't carry over when I did my formatting. So write a situation to be modeled with this arithmetic sequence. Okay, so I've got a sub n equals 10 plus n minus 1 times 4. So I know that the 10 here is my first term. So that's my first term. And I know that this 4 is my common difference. And since it's positive, I can know that it's increasing. So I need to think of something that could start at 10. So this is going to be something like 10, 14, 18, 22, 26. Well, what can I do? What can I figure out for that? So maybe, let's see. How about someone who does like babysitting? Maybe this is babysitting, how much they get paid. So let's think about that. So let's say Kiera babysits and gets $10 for the first hour. And $4 more for each additional hour. For each additional hour. Any situation where you start at 10 and increase by 4 each time would work for this. Okay? So go ahead and try to think of a situation that you can write for this, and then go to your work, and I will see you in class.